Hi, I'm Owen from 9146N, and I want to do a little explanation of our winter robot for this season. This is our third robot this season, and we've taken it to two competitions so far, and it's just worked out for us very well with them. So I just kind of wanted to explain like the design of this robot and like why we did certain things on it, and hopefully someone will learn something from it. But yeah, let's just start off with our drivetrain. So our drivetrain is 450 RPM on 3.25-inch wheels. And we chose this ratio because we really like the high speed of it, but also like you could have like the quick acceleration as long as you like maintain a lower average weight. And so one thing that we did that's a little different on this robot, we swapped the position of the gears and wheels. We have the gears on the outside, and this kind of like brings the wheels more into the center of the robot, and this like tightens the turning radius. It makes turning a lot quicker. And we just found like this makes the turning like maybe a little bit quicker in Auton. It just kind of helps with saving like that a little bit of time here and there, especially during skills. You can see our odon pods here. We have one vertical, one horizontal. The vertical odon pod, really simple, just a nice little lever on this like high strength cross brace. This just worked really well for us. It didn't really interfere with park as well because it could still flex up enough. This other tracking wheel is what we call a linear odon pod. The way it works is like this shaft here can like slide in this like little pocket in the Delrin plastic right here. And so this allows like just straight up and down motion. We found this like really gave us nice consistent contact with the ground, because before we had like a lever design that would like push into the ground, but we found like because of this like tight space in here, the lever had to be like at a really steep angle and give kind of like almost like a bias to one side, where when the robot like moved that direction, the wheel would like track fine. But when it moved the opposite direction, kind of like against the way the lever is pulling down, the wheel would skip a lot and just cause a lot of inconsistency. So that just wasn't really optimal for us. I think that's it for the drivetrain. I'll move on to the intake now. Our intake is just a basic Ruguan style front to back intake. We chose front to back just because like getting to the match loader and then back again to the goal with the front to back intake is much quicker, as you don't have to like waste that time turning around. Because on our previous two robots, they were front to front, and it was just kind of annoying, honestly, like as a driver having to turn around. But that's why we kind of switched that front to back style, just to give us that quick cycle times. So, oh, actually, one more thing I forgot on our drivetrain. We have these like poly or Delrin sleds right here, and these sleds were designed in Fusion 360 and CAD. And this like little like slope right here runs tangent to the circumference of the wheel, and this really helps just pop the robot up off the ground when going over the barrier, and just gives us a really consistent barrier cross. Another thing we did is that like you can see the 36 tooth gears that mesh with the 48s. They kind of stick below the seat channel a little bit. This means that they will like contact the park bar as the robot goes over. But you can see on this side, we designed the plastic to go low enough to cover up these gears completely, so that way they don't scrape against the park barrier and just kind of grind away. All right, now on the intake, we run like three separate stages. We got our initial front stage here, the flaps, and then our scoring hood part. So the front stage down here is where our flex wheel intake is. This runs on like a high strength shaft at 600 RPM. One thing, or I should say a couple things that we did that are interesting on this part is we have a compression ramp here made of latex tubing. And this is like really flexible because this intake is stationary, because we couldn't make a consistent like floating intake just because of the really short distance from this channel to where we wanted to go. It would mean that the arm of the intake would just have to move up so much to account for the blocks, and also like to getting a chain that'd be tension to that and not hitting the flaps and jamming. It was just a not great tuning process. So we just opted for going with the stationary intake that could still consistently pick up blocks. And so the way this works, we also have these like flex wheels here that compress a lot because we cut out the spokes on them. I don't know if you can see that right about there. We just cut out those inside of the spokes with like some tin snips, and that just gives the flex wheels like a lot more compression. So because the intake isn't floating, it just really accounts for that. And you can see it picks up the blocks really nice off the ground, just gives us really consistent picking up. And like one thing that we kind of did, like when we were tuning this, we adjusted the distance from the ground to the block just to be like minimal as possible. So like you can see the block is like barely touching the wheel. And this is nice because if the wheels were lower, the block would have to overcome like a lot more like compression to intake into the robot. But because of the height of the blocks, it doesn't have to. It can just easily pick them up. And it does like less wear on the motor. It just like really helps during the match. So yeah, the flap stage, it's just basic flaps. We just use 6-tooth sprockets just because of this spacing. It was really hard to fit the larger ones, but in the future, we definitely want to go with the larger sprockets because the rim speed on those is higher and the speed is higher. Because right now you can see the flaps are a little slow because they're running on one 600 RPM motor down here. So it just kind of decreases the time between each cycle and just scoring speed. And that's like something we want to improve in the future on our rebuild. So once we get up to the scoring stage here, we have this roller made of mesh, and we opted for making this out of mesh because we found that there's like a little dead zone here, which is kind of like around where our band is pulled down for mid scoring. And this just like wasn't really ideal because it would slow up scoring one. And also like when we were intaking, when we wanted to score on mid local, we can't have the block like all the way up here because like it opens up down here and there's like one extra band here. I don't know if you got like one extra band right here and then it opens right here. So we don't want blocks like at the top of our intake. So we need this like mesh roller to spin reverse slightly just to hold them back. And that mesh gives us a lot more contact with the block and the ability to do that. The scoring stage is like powered by one 600 RPM motor right here. And it's just direct drive. We chose to do direct drive because we didn't want any chain like this, like a longer chain going like from the bottom of the robot up here. Cause that just like can break really easily, and if that's broken then we can't score, and so we just want to reduce those like single point failures. So then it takes us to our like next part of our hood, which is like this rubber band roller here. We chose the rubber bands just because like they compress to the blocks a lot more instead of flex seals, and just because like they could still the hood can float a lot and it can compress, so it just gave us like really consistent movement on the blocks when we were scoring, which I can demonstrate soon. But yeah, that's kind of why we chose to do that. I'll just show the scoring a little bit. So yeah, you can see with the scoring, we tune the scoring to actually shoot the blocks further into the long goal, because during autonomous period, the long goal control zones are added to the autonomous bonus. So it's like really important that a robot is able to push these into the long goal. And this actually saves a lot more time than using our wing, especially in like qualification matches where teams might not have like wing autons and we still want to get that control bonus to jump ahead of the other alliance. It just really helps having that ability to shoot blocks further into the goal. And so part of our intake performance that actually helps with like this quicker scoring, I should say, is these Delrin funnels on the inside of our robot. These funnels are a little different because one you can see is actually bigger than the other. And this gives like what we call like asymmetrical funnels. And this really helps the blocks funnel one by one, because if the funnels were the same, the blocks would have like the same opposing forces that they push against with the funnel. So it just really jam up the intake. Excuse me. And that's just not ideal because you want the blocks to be coming out one by one as quick as possible. So that's why we opted for doing these one long funnel, one short funnel, like asymmetrical funneling type. Yeah, now I can talk about our mid-goal scoring. Our mid-goal scoring's pretty interesting on this robot. We have a piston right here that pulls the band and opens it up in our intake. And so when we do that, you can see that this counter roller actually starts spinning. And this spins in a direction so that when the blocks touch it, it kind of like rolls them into the mid-goal a little bit. We found this to be like a little bit better than a top roller, because a top roller, it gets like that really aggressive push on the blocks in mid-goal, and that can kind of cause like some inconsistencies when you're trying to fill up 7 blocks exactly in skills, for example. And so that's why we kind of opted for this like smaller, lower roller that just kind of gave the blocks like a lighter force. And so yeah, the counter roller is powered by this chain right here that's connected to our scoring stage. And this is like, we chose to do this because when the scoring stage spins in reverse, sorry, that's reverse, the counter roller spins the direction it needs to. And this is intentional because when a block is up here, it spins this in reverse to bring it back down to the position you can see right here where this opens up. And then it spins these forward, kind of pushing the blocks like this middle position here, where they can then be scored into the mid goal. And I can demonstrate that here real quick. So here's that demonstration of our scoring. Yeah, it just gets 7 nice and consistently. The counter roller just really helps get that light push that the robot needs. And it's just really good for skills, just because this bonus is worth 10 points and the block still, it's like a 17-point bonus in skills. So that's just very helpful. Last part about like our mid scoring is our middle goal D score right here. And so this allows us to quickly like change the tide of a long, or change the side of a long goal. So, or a mid goal, sorry. And so like what this does is like sometimes during the match, like you don't really have enough time to score your blocks into the mid goal to regain a control zone. And so to counteract this, just because like the mid goals are just like heavily contested and like the matches we played during like the majority of the match, it's just kind of helpful sometimes to be able to have the ability just to hit all the blocks out of it. Because if you're descoring all the opponent blocks, that's still a positive gain for your alliance because it brings the match like much closer together. Another like good benefit of it is that if you have a block of your color, for example, in the top here, you can use the mid goal D-score to just push it more in and then push out all the blues. And that's just really good for just quickly changing the score. Yeah, the next part about our intake is our match loader. Our match loader is just one piston. We use C channel on our match loader because we saw like most teams use one by, but we didn't want to deal with like one by bending at all, just because that's like one thing that we had to fix at a competition. And just making this out of C channel just made it so it's one less thing that we have to worry about. We have a high strength brace that goes across the whole match load mechanism. And this is like box inside the one by, so it's just really strong and rigid. And it's also triangle braced here with standoffs and high strength block colors. And so the actual match load piece itself pivots on the high strength shaft using these 3 zip ties across it. And so you might be thinking like these zip ties, they look pretty jank. Like, I mean, like, why are we running those? But these 3 zip ties were actually like the first ones that we put on this match loader when we made it. And they're still fully intact now. So like we found this like works really well. And it's just super simple and like really easy to make. So that's kind of why we've done this. Yeah, the match load, simple rotating match loader. So as it drives in to the goal, it follows the curve of the back plastic and just like tilts the match load piece down to allow blocks to flow into our intake. And I can demonstrate that now. So there you can see the match load is just really quick, nice and simple. It's really good for skills because it really helps like bring the blocks out quicker. And that's just really helpful for just saving time and pushing higher driver skill scores. That's almost it. I think the last thing we have to talk about is our wing mechanism. It's a pretty basic wing mechanism. It uses just one piston, a short one. And so like one thing that we do that's kind of unique, I would say, but not too much because I've seen a lot of teams doing this, is that the lowest state of the wing is actually like perpendicular, or sorry, horizontal or parallel with the ground. And so like what this does is that when it's flat, it allows the robot to drive into the goal directly and push blocks when it's in its lowest state. And so this is really nice because before, like a lot of teams I've seen have wings that like go down all the way and then they have to like bring them up and then bring them back down again to move goals in the long tubes. And this is just not really ideal because you have to do so many motions and it's a lot harder to line up than just having a wing that sticks out the side of your robot that you can just drive in. And it's able to quickly move up to just avoid those like goalkeeping violations. And that's just really helpful, not accumulating violations for elims where the long goal plays actually matter a lot more. So that's kind of why we did that. The next part is our aligner here. It's made of like one piece of Delrin, catted in Fusion 360, but we hand bent it with, I think it was like a lighter. We just put the flame on like really low and just kind of like slowly heated it up and then bent it. So that way when the robot drives into the long goal, the aligner kind of like keeps the robot at a right distance where the wing can always push straight down into the goal at the right distance from it. And that's just really helpful, like as a driver, having that backup just to keep the wing aligned at all times just makes those wing plays a lot easier. And so, yeah, I think that's pretty much everything on this robot. If you guys have any questions about anything, just leave them in the comments. I'll be happy to answer them.